Hey, this is Jason Holmberg from WildMe. I want to show off the new deep learning-based pose invariant embeddings matcher. This is using pose invariant embeddings, the algorithm in its second version, as developed by Olga Moskviak, who is a PhD candidate. Pose invariant embeddings gets the top result about 81.5% of the time, and top 12 into the 90s. So this is an evolutionary leap ahead of the aging capabilities of the modified growth algorithm. And I want to show you how to use it because it is now usable for all data in whaleshark.org. Now, we're in a hybrid state where whaleshark.org is merging its matching capabilities, its matching workflow with that of the rest of the wild books, which are a much more standardized user experience. Whaleshark.org has always had the crop, rotate, and spot mapping. We're still going to have that. Modified growth is still going to be available for use. But as part of the crop and rotate, we're also going to be creating something that's called a candidate region annotation, which is really just the crop photograph that we create for spot mapping, but we're making it usable and matchable by pose invariant embeddings. So we're going to start with this new unassigned encounter, just like we would any other encounter in whaleshark.org. A priori, I know this is from North Ningaloo, but I don't know who it is. So I'm going to go ahead and do spot mapping, just like we've always done. Going to do a very quick crop rotate. No changes to this process at all. Oops. Still clicking the spots because we can still use modified growth, which depends on these spot mappings, but pose invariant embeddings does not. It looks at this whole square image. All right, let's go ahead and click Save. Now at this point, I can click Start Scan Task, just like we did before, and run the modified growth algorithm. Why not? And you can see my scan task is off and running. But I can also click Return to Encounter, and you're going to see something new. It looks like an additional image was added to this encounter, but what was really added is an additional annotation. So we created a machine learning construct represented by this square. You'll notice that it has the CR image or candidate region image keyword. It looks very distinctive, and it's an exact clone of the candidate region down here that we use for modified growth. Now, scrolling back up to it, here's where we get back to a consistent workflow with the other wild books like Manta Matcher, where we can just click and say Start Match. This is how most wild books work when whether it's Fluke Book or Whisker Book, working with computer vision for different species. Click Start Match. Notice it's only these candidate regions that are matchable. If you click here, there's no matchable detection. It's only these candidate regions that will have this menu option Start Match. Now, our standard wildbook dialog box pops up. You'll see that PyV2 pattern matching is available and it's used by default. No need to use Hotspotter. We have that on for benchmarking, but we know it doesn't work very well for whale sharks and may eventually turn that off. But we also have the ability now to select which annotations from across the global data set do we want to match against. Now this encounter is 1A1, so automatically North Ningaloo is selected. But let's also add South Ningaloo and Ningaloo nonspecific, and let's click Match. I'll pause the video for a minute, but we're probably going to be matching across 11,000 or so annotations. It should take just a couple of minutes, and in fact may finish before the modified growth. Now, an important difference is that the modified growth algorithm is not going to be matching against 11,000, but it by default is matching against 39,520, the global data set, of which it then will present a subset that are relevant for 1A1, 1A2, etc. Whereas with pose invariant embeddings, we selected exactly what we want to match against, and that helps limit false positives. All right, might pause the video here for just a minute or two while these results are running, but it won't take long. All right, Pose invariant embeddings is back. You can see that it has a top 12, but you can adjust the numbered results right here. Let's look at the top match. This is in fact looking a little promising. Yep. All right, a priori, I didn't know who this was, but this is definitely looking like A1429. There's a pretty strong score differential between the next best candidate, so that's good. We're still figuring out what range of scores we get back from pose invariant embeddings, so we may boost these scores a little bit so they're a little more readable. But I think right off the bat, pose invariant embeddings has made a match. Let's go ahead and click here and say set to individual A1429. And there we go. That encounter now belongs to A1429. At any point that we want to run this annotation again, we can come down here and do start another match, or we can say match results. So match results are a little bit easier to get to now. But we can also randomly just go to a particular whale shark, A001, Stumpy is one of our favorites. And all the historical data has been converted so it's compatible with pose invariant embeddings. And you'll see here's the extracted pattern region, and I can just click start another match and kick off this process again so that you can test it against the historical catalog, look for matches that modified growth might have missed, use this for new encounters, etc. All right, please give me feedback on what you think about pose invariant embeddings. Thanks a lot. Bye-bye.